Okay, we're going to continue. I just want to correct one thing. This was 775 right here. So this changes to 221, which is totally fine. We'll just change it over here to 221. Okay, so now on the bottom n, which is 8 times the sum of the x squared. So we go to the x squared column because that's in brackets, and we go to 11,712. So we put in 11,712. Okay, and then we have to do subtract. And take a look here. This right here is the sum of the x's, and that's the only thing in brackets. So that's what we take, the sum of the x's, and then we have to square it. So we got 292 squared. Okay, now let's actually simplify the top. So I get 8 times 13, 221, minus 292 times 329. I get 9,700 for the top, for the numerator, and we have 8 times 11,712 minus 292 squared. I get 8432 for the denominator. And when I go ahead and divide those, 8432, I get 1.150379507, and so on. Okay, so we'll round to 1.15. Now we want the equation of the line of best fit. So we know it's going to be in the form y equals ax plus b, which is 1.15x plus. Now let's solve for what b is, and remember b up here. Let's change colors. Let's go blue. Okay, b is going to be this equation where y bar is the average for the y's, and x bar is going to be the average of the x's. Well, we know that the y's all add up to 329. It's right here, right? And then we have the x's that add up to 392. Well, 329, and we just have to divide that by 8. Subtract the 1.15. And x bar is going to be that 292 divided by 8, because it's going to be the average of the x's. So when you add up all the x's and then divide them by the number of values. Okay, I can put this whole thing in my calculator. 329 divided by 8 minus 1.15 times 2 divided by 8. I get negative 0.85. So our entire equation for our line of best fit, which is completely exact, so a little bit different than we saw in grade 9, is y equals 1.15 minus 0.85. If you want to do all of this work in a very short amount of time, all you have to do is type the numbers into Excel and then insert that scatter plot. Okay, when the scatter plot's inserted, I would just quickly change the layout. So you can just scan through these. If you forget which one, you can scan through these. And as you can see, like this one offers all the points and the actual coordinates that go with it. This one doesn't. Okay, some of them have axis titles, some of them don't. Keep clicking through them or skimming through them until you find the one with the actual equation. So is this the equation that we have as well? Y equals 1.1504x minus that 0.8. They get 0.8639. Might just be a rounding error. That's totally fine. In addition, for this one, we have r squared, and we can just equal square root. If you want to know the regression from section 3.1, 0.9654, and this is what r would equal. R equals 0.982548. This is a strong positive linear correlation if you wanted to get that extra step. And then of course the chart titles, income over the years, that's fine. And then chart axis up the side is going to be annual income, and it's measured in thousands of dollars, and here it's going to be age, and it's going to be measured in years. I'm sorry, for a title I should have capital probably there and there. And that's it. So pretty quick when we are using Excel. Now, going back to our PowerPoint. Okay, we used a scatter plot to classify, and then we, of course, double checked it. We find the equation of the line of best fit analytically. We did that. Now, let's actually use our line of best fit to predict the income for a new employee who is 21, and then for somebody who is retiring at 65. So 21 and 65. So all we have to do here is take this equation and sub in those 2 points. Okay, so I've already wrote these down. So we have 21 and 85, so being the age. So remember, age is along the x-axis, so we can put in when x equals 21 and then when x equals 65. Then what we're going to do is we're going to actually take a look, is this practical? Okay, so at 21 years old, when you're starting in this company, if we can just simply punch that in our calculators, and then I'll write out the other one as well, 65. Okay, so 1.15 times 21 minus 0.85, I get okay, 23.3. So this would be equivalent to $23,300. Because remember, this goes over those 3 zeros. And the same thing for a guy that's 65 years. So maybe 73.9. So this would be equivalent to earning 73,900. Okay, is this practical? Is it practical for a 21-year-old to get out of college and make 23,000 and then eventually get a raise to 73? This is a huge jump. Like the range between these two numbers, 73,900, is $50,000, 50,600. So the range is 50,600. So depending on if you're on commission, if you're doing sales and you're making a lot more money because of what you're selling, you could potentially make this. Also, and they could have the person starting at 21 on probation. So the individual on probation could be making like a small amount of money. I mean, 23,000 is not a lot of money if you actually divide that hourly. So I would say divided by 52, divided by 40, 52 weeks a year, 40 hours a week. It's only 11. This would be equivalent to like $11. Just over $11 an hour. So do I think that that's practical? No, unless this person's perhaps an intern, perhaps just coming out of school, or maybe still in school as maybe a summer student. But this is still under minimum wage, at least in Ontario right now. So I would say, no, that's not practical. I would say that they would probably start a little bit higher. 73,900, it could be practical, absolutely, by the time you retire.